right, today we are going to talk about multiplying and dividing rational expressions. And this you actually did in Algebra 1, so hopefully once we look at a couple of them, it will seem familiar to you. So we need to be able to simplify rational expressions that have polynomials, and then we need to be able to multiply and divide those rational expressions that have polynomials. I've got a little list here of the order of the steps that you should take. First, number 1, factor all numerators and denominators completely. I said at the beginning of the year you have to be able to factor in Algebra 2, and here it is again. You have to be able to factor because it's step 1 and you can't get to the rest of the steps if you can't factor. Once we have it factored, we can reduce all the common factors, meaning we can cancel them out, the things that they have in common. The key is the factors have to be separated by multiplication. Know what I call hacking. So for instance, if you have something like this, x plus 5 over x, this x and this 5 are not separated by multiplication, so you cannot just cross out the x's. Here, other than separating it into 1 plus 5 over x, there's nothing else that you could do because, again, the x and the 5 are attached. You can only reduce the factors that are separated by multiplication. Once you've done that, you can perform any operations if there are any. Again, sometimes it's just simplifying. So once you've factored, reduced common factors, if there is multiplication or division, you can do that. And then sometimes you'll need to reduce or simplify again. Not all times, but sometimes. So let's look at example 1. So first step is to factor numerators and denominators. So I look at the top, and I see there's no number in front of the x squared, so this is factors that add, so I'm looking for what multiplies to -6 and adds to -5, which should be -6 and +1, so that factors into x minus 6 times x plus 1. The denominator here is a difference of squares. They both have perfect square roots, and there's a minus sign, so this factors into x plus 1 times x minus 1. Now again, when we go to reduce the common factors, it's only factors that are separated by multiplication. Here's the multiplication in the middle here. So the only things you can factor are reduce are the entire parentheses if they have them in common, which they do here. You see x plus 1 and x plus 1. So we're going to reduce those, and then that's going to leave me with x minus 6 over x minus 1. That is my final answer. Again, you can't reduce the x's because they're attached to the 6 and the -1 by subtraction. Can't separate those. So this is our final answer here. All right, I'd like for you to go ahead and try B and see what you can come up with. So pause it for a second, try it, see if you can do this problem because it's going to get a little more complicated after this. All right, so hopefully you factored the top into x minus 3 times x plus 1, and the bottom factored into x minus 3 times x minus 4, and then hopefully you canceled those x minus 3's. Final answer, x plus 1 over x minus 4. Okay, so those were the simplifying ones. Now we're going to look at ones where you have to multiply. So these ones, notice everything is multiplication, which means everything is up for grabs with reducing. You can reduce up and down. You can reduce across, just like you can when you multiply regular fractions. So it's up to you the approach that you want to take. Some people prefer to reduce first and then multiply. Some people like to do it the other way around. I usually make my decision based upon how big the numbers are. These ones aren't huge, but the 18 is big enough that I would probably at least reduce the numbers first. If you don't want to do the letters, again, you can multiply straight across first if you want. I'm going to reduce this 6 with the 18. They're both divisible by 6, so that becomes a 1, and this becomes a 3. I'm going to reduce the 2 and the 10. So 2 divided by 2 is 1, and 10 divided by 2 is 5. So now I can reduce the variables as well. I've got x squared over x squared, so those just cancel each other out. The y cubed over y squared, that just gives me a y in the numerator because I'm subtracting. So the 3 goes away and it's just plain y is all I have left in the numerator here. In the denominator, I've just got a 1. Over here, I don't have x's to reduce, but I can reduce my y's here. Y to the 4th over y squared is going to give me y squared in the numerator because 4 minus 2 is 2. So in my numerator there, I've got 5y squared. In the denominator, I've just got a 3. So then multiply across, y times 5y squared is 5y cubed, and 1 times 3 is 3. There's nothing else I can reduce here, so that is going to be my final answer. All right, if we look at the middle one here, need to factor because I've got addition and subtraction. So the top, that factors with a GCF. I can take out the 2x, and that's going to leave me with 2 minus x. On the bottom here, this is x minus 3 times x minus 2. And the top here is x minus 3 times x minus 1. So when I go to reduce these, I pick these problems very purposefully. You'll see the 2x's canceled here. The x minus 3's cancel here. Now, the reason why I picked this problem is because of what you see here. These are not the same thing, but they're very close. Here the 2 is positive, here the 2 is negative. Here the x is negative, here the x is positive. When you have this situation where they are both opposites, not just one, so we're not talking x plus 2 and x minus 2, we're talking about both the x and the 2 are opposites of each other, these can be reduced. You can cross them off, but when you do that, you replace it, instead of just making it a 1, you have to make it a negative 1 because they were opposites. So now in my numerator, I've got a negative 1 times x minus 1, so negative x plus 1 when I distribute it. On the bottom, everything canceled. It's just a 1, and we don't have to write denominators of 1, so that is our final answer. Same thing here. We're going to factor. Notice there was no denominator. If you feel uncomfortable having no denominator, make it a 1. Just make sure you don't do that in your final answer. All right, so factoring this top here, there is no GCF, and it looks like you would check it to be a PST because they both have perfect square roots, but the middle term is not double this. So then you might look to see if you could factor it with split the middle. You'd be looking for what multiplies to 36 and adds to negative 6. But when you look at that, there is nothing. There's nothing that multiplies to 36 and adds to negative 6. So this is not factorable. So let's look over here. This is a sum of cubes. So cube root of 27 x cubed is 3x. Cube root of 8 is 2. And remember that this is SOAP. So we did the same sign, then we're going to do the opposite sign, and then the last one's always positive. Remember that we get this one based upon this one. So we square the front to get the front, so 9x squared. Middle multiply, so 3x times 2 is 6x, and square the back to get the back. So what has happened here is that after we factored, even though this wasn't factorable, now that cancels with this one. The x plus 2 and the 3x plus 2 can't cancel. Again, the 2's are separated by addition, not multiplication. So our final answer there is going to be x plus 2 over 3x plus 2. Example 3. Exact same thing as what we did in example 2. The only difference is, since it's division, that means you flip the second fraction. Or if it's not a fraction, you still reciprocal it. So you multiply by the reciprocal. So what I usually do first is I usually just rewrite it first as a multiplication problem. So times, and then flip the numerator and denominator here. And now it looks exactly like example 2. So factor here down at the bottom. This has a GCF of 4. This has a GCF of x. This is factors that add. What multiplies to -6 and adds to 1 would be +3, -2. And so now I can cross reduce. I've got an x minus 2 over here and over here. I've got x plus 3 here and here, so those cross reduce. So in the numerator, the only thing I've got left is my 3 from over here. In the denominator, I've got a 4 here and an x here. So 3 over 4x would be our final answer. All right, on this one, again, the first thing I usually do is rewrite it as a multiplication problem. Remember that you're flipping the second part. So this was over 1. Now we're making it 1 over 4x squared minus x. So when I go to factor, this top up here, that is going to be a split the middle because there is no GCF. So I'm looking for what multiplies to -24 and adds to 10. So -24, I could do 12 and -2, and that would add to 10. So I'm going to split the middle term. Notice I'm putting my work over here for the actual factoring. 8x squared plus 12x minus 2x minus 3, and factor it by grouping. So first group GCF is 4x, which would leave me 2x plus 3. If 2x plus 3 is brought down to match this one, then the only thing I would need is a -1, because what I multiply 2x to get -2x is just -1. So that means my factorization up here at the top is 4x minus 1, coming from here, 4x minus 1 times 2x plus 3. On the bottom down here, that has a GCF of x, and that leaves me 4x minus 1. Notice how sometimes when you factor one, it might give you a hint as how to factor the others. Not always, but usually you're going to have at least one thing cancel. So my 4x minus 1s are going to cancel here and here. So on the top, I've got 2x plus 3 times 1, so that's just 2x plus 3. On the bottom, I've got 4x squared times x, which is 4x cubed. Again, you cannot reduce these because the 2x is attached to the 3 by addition. All right, so now example 4, we're just taking it one more level, and we now have multiple operations in the same problem. So what I'm going to do is any divisions I'm going to flip. Multiplications stay how they are. So my first one stays, x over x plus 3. Second one stays because it's multiplication. Now I am going to make it with a denominator of 1. The third one, that was division, so it needs flipped. So I make it x plus 3 over 16x squared minus 1. So now I'm going to factor, and there's not a lot of factoring to do here. These aren't factorable, these aren't factorable, this isn't either. The only thing that's factorable is this. It's a difference of squares, 4x plus 1 times 4x minus 1. So this cancels with this. These are across, numerator, denominator, so those can cancel. So in my numerator, I've just got x. In my denominator, I've got 1 times and then just 4x minus 1. All right, the last one, please try it yourself. Notice that they are both division. Try it, see what you can come up with, and then unpause it to check your answer. So first thing I'm going to do is rewrite. Since this is division, I make it multiplication and flip, so 2x plus 3 over x. Second one is also division, so I'm going to flip that as well. X minus 2, 4x squared minus 9. Now I need to factor. So doesn't factor, doesn't factor, doesn't factor, doesn't factor, doesn't factor. So just like the other one, the only thing that factors is this last one. That's a difference of squares. It's 2x plus 3 times 2x minus 3. So I can cancel the 2x plus 3's. I can cancel the x minus 2's. I can also cancel these x's. So everything canceled in my numerator. That doesn't mean the numerator disappears because it is a 1, and we do need 1's that are in the numerators. So 1 in the numerator, in the denominator, the only thing left is the 2x minus 3. And so there is our final answer. And that is it for this lesson. If you are struggling with factoring, go back and watch one of the factoring videos again. You have to know how to factor. That's it.